In this video, we look at the implementation of the microwave using the state pattern, the observer pattern, and the timer class. This implementation eliminates all the conditionals that can be eliminated. So the clock looks like this. The main difference between this version and the one that we saw initially is that this is now implementing the observable part of the observer pattern. We have a property change support object. So this is an adapter, an object adapter using the property change support for keeping track of all the listeners. So the listeners are implementing the property change listener interface in Java Beans, and this makes them uniform. No matter what their actual types are, they are all property change listeners, and we add this listener to the property change support using this method. The run method, as usual, or as before, sleeps for 1 second and then fires the property change. The property name, old value, and new value are parameters, but they are not important here because the only property is the fact that the time has advanced by 1 second. The previous value or the new value is immaterial. So whoever is listening to the clock will get notified every second. And in this implementation, the only class that gets notified or that is interested in the clock is the timer. So the timer implements property change listener, so it is an observer. It keeps track of the time value left and who its client is. The client is a notifiable, regardless of what their actual type is. They are all implementing notifiable, and that's all the timer cares about. When a timer is created, the notifiable sends its own reference and the initial value for the timer. They are stored, and the timer object adds itself as an observer, as a listener of the clock. We are changing all event handling methods to the same name, handle event. So every event handling method in this implementation is having the name handle event, and the type of the event distinguishes the methods. So here the notifiable class has two handle event methods. One is when the timer ticks, and then when the other is the timer running out. So here is the timer code for its methods. When the time value is to be increased, it adds that value to that field, time value. And when the timer stops, it removes itself as a listener of the clock. So it will not be notified of further property changes, so it will not bother its client anymore. Otherwise, if the clock notifies that the clock has ticked, we get information about that event, but that is of no concern really. We decrement the time value, and if it is touching 0, we call the handle event of the client with this instance of the timer ran out event class. So that is one of the events, and it stops listening. Otherwise, it tells the client that the timer has ticked. So this creates a new object with the time value. This is the only place where the an event class is instantiated in response to events. In all other cases, we are using the initial instance, the only instance. We are using all others as singletons, like timer ran out event. And we saw that we are going to have a GUI button class that is the superclass for all buttons. And when we create a GUI button, we need a string that goes into the button object. And we say that every button is going to listen to itself. No one else worries about the button. So when the button is clicked, set on action, when this button is clicked, this object, this button itself is going to listen to it. For example, the cook button, its constructor has to call the superclasses constructor with cook as the parameter, but the handle method to take care of clicks would call the handle event method of the context. Every event other than the ones related to the timer go through the context. So the context has a handle event for every event type except the timer events. So the cook request event instance is passed as a parameter. So we go to the correct method. So the context has one method for every event except the timer events, but the microwave state class has a handle event for every event, including the timer events. And the enter and leave methods are abstract, as we have seen in the UML diagram. And here are some examples of methods for handling events in the context. When the cook request event is received, this method gets called, and it calls the current state's handle event for this event. So it will go to this method. The default is to do nothing, but the door closed state will have some implementation for it, or the cooking state will have some implementation for that. The door open state will not override it. Similarly, we have methods for door open event and door close event.